talk how to continue to work with Jupyter Notebook and make your machine learning experiments reproducible and automated with DVC. So we'll talk how DVC can help and how actually to switch from Jupyter Notebook to the Python code and run it in a terminal, or how to use both of these tools. So purpose for this presentation is actually, and for this approach, is speed up your machine learning experiments, make your machine learning experiments and pipelines reproducible, and simplify collaboration in your team and project. So let's start. We'll follow these 4 steps. First one, we'll create a single configuration file to keep all configuration parameters for our experiment pipeline in one place, and it will make us the single point to configure experiments and run it. Then we'll move some code away from our Jupyter Notebook to Python models and import them back into the Jupyter Notebook. And then we'll start with building ML experiment pipeline and automate it. So let's start with the first step. Really easy and without any actually the coding skills or software engineer. Imagine that in our common approach with Jupyter Notebooks, when we have or start with some proof of concept, we usually do prototype in Jupyter Notebooks. So this is example of with iris data sets and simple model for classification. So we load some data, look inside what kind of classes we have inside. Then we do some simple feature engineering, split for trained test data set, then train the simple logistic regression model, and evaluate it. For evaluation, we will plot some confusion metrics and calculate F1 score. So this is quite easy and the basic Jupyter Notebook for the simple model. But anyway, it takes a few screens, and I already need to scroll down this Jupyter Notebook to get the right place. Usually when we work in real life projects, these Jupyter Notebooks becomes very large, and it's not easy to navigate. And in such notebooks, we have a lot of different configurations, like, for example, how we process the names of columns, and how we calculate our features, and actually what kind of features, what name of them we'll need to take into the final data set for training, or like a test size before we split, and of course the hyperparameters. So all of these parameters or configuration for all of our experiment, they are spread out into all these Jupyter Notebooks, and it's can be very difficult to find the configuration that you really need to change, and after that rerun the cells that depends on this parameter. So what we can do is to take all of these parameters and move them into one single params.yaml file, and that's it. And this params.yaml file will look like some few sections, and we can take this configuration from this params.yaml file and input into our code. So how it will look, for example, for our simple classification task. Let me also share my code. Okay. Okay. I think that now you can see my screen and my code. It's that big enough to easy navigate and follow me. And what is idea under this params.yaml file is to split all your configurations into the small sections. Each section actually relates to one of the stage in our pipeline or in our experiment. So we have the first one, we have the base section, which is a global for our experiment. For example, it's some name of our project or a name of our model, but usually it's a random state and some other similar configs. And then we have few sections for data loading, so for feature engineering step, then splitting data and training. And for example, for training, we can put inside the few configuration for few estimators, and for each of these estimator, we'll add parameters. For example, for a log-variable baseline that we use for the first one is just a simple the list of the parameters, and for not this, but a few parameters, but for log-variable and SVM, the next estimators, it's suitable for doing some grid search. We start with the for baseline. It's just we need to take these parameters, load them into the Jupyter Notebook, and use it. So it looks like this. We just create simple function that can load this data from params.yaml file and return the object that can be used to navigate to the required parameters. And we'll use this object, for example, in a split train test to specify what is the test size we need to use for this train test split function. So after we do this, so actually the notebook that we use, for example, didn't change. We just substitute the hard-coded parameters with the parameters from the config file, and we also did this for training. For this logistic regression, we used parameters from our params.yaml file. So this one. So it's quite simple step, but when you work with in a team, and you have the huge Jupyter notebook, it can help you to organize all your parameters and make your changing your experiments easier, I can say. Okay, let's continue. So we have done with the first step. Let's talk about how we can start using scripts in .py modules. Actually, this is also quite simple step, and we don't need to do something about the software design first, and we can just look into our Jupyter notebook, see that we have some the large portion of code or already some functions inside, and just move them into Python modules and import back into the Jupyter modules, and that's it. And this will add us first the much cleaner Jupyter notebooks, and we can start using Git for versioning our code. So let's look how we can achieve this. First of all, we need to organize our code repo. In repo, first, all our Jupyter notebooks we will store in notebooks directory, and all our code that we'll use and we'll store in SRC folder. So actually, this is arbitrary structure inside, so you can name it as you wish, but usually it's easier to name it like the also the for type of tasks you do with in your experiments. Like here, you can put all scripts related to data processing and feature engineering. So for training, of course, it is some code that can be reusable for training models, etc. And in real life projects, usually we don't add Jupyter Notebooks into the Git under the Git control, and we just then keep them away. But we always have this notebooks folder, and during the experimentation, we put all our Jupyter Notebooks inside. Okay, let's look how what we'll get and how we can do this. For step 2, we have started with the same load_params.yaml step, and then we go to the get dataset. So to get dataset, so actually it's a loading. So in this Jupyter notebook, we just load this data from sklearn datasets and do some column names processing. So this is some simple, but still this is a code with some processing. So we can just wrap this code into the simple function get dataset that will do all this logic inside and return the dataset, the clean dataset we can use for feature engineering. And also we can use some function to get final names of their or process the targets from the data. So what we can do, we first wrap this code into one function, move this function into src datasort.py, and then import this back. So here we just import these functions, and they can do the same job, but it makes us our notebook is much cleaner, not much, but a little bit cleaner and smaller. And if we look into our code, so in the src dataset, here you are these functions, get datasets and get target names. So this is the first step. Second one is a feature engineering. So we had this code into our Jupyter notebook. So let's also wrap this into the simple function. Also, one of the benefits when we do this job, we can prepare additional tests to test that this code that extract features from the data actually works fine and works in the way we expect to do this job. So we can write some unit tests and test our code. It's not necessary, but this is just a good practice. So for feature extraction, we also move this code into Python models and then import it here, and that's it. And we run and get our features data set in notebooks. And we can continue with this. And of course, for example, for the last step where we used evaluation, we had some function that plots the confusion matrix for us. And actually this function I took from some resource, some internet resource. Yeah, here the link. And this is quite, first of all, is ready to use function. It's quite big, so it's not really good to have this cell with this function in my notebook. So I just move it into my Python model into the evaluate model. So this one, not this one, but somewhere there. Okay, I don't remember actually where I put this. We'll find it later. What confusion matrix in SRC report? Okay, yeah, here's another model. Okay, and here we just import this and we get our confusion. So this is the approach. So we can start with the code that is already suitable to wrap it into the function, or we already use some function and reuse it, and then just move it into the Python modules and import that in notebooks. So let's look how our Jupyter Notebook will look like after we'll do this. Actually, we start with some common importing commands, then load params, and then very clean and short cells in our Jupyter Notebooks. Calculating features, splitting, and do some training and evaluation. So easy to navigate, easy to test, and our code already is under the Git control, and we can keep our code versions in some GitHub or GitLab repositories and share with our colleagues. So it's easy. Let's continue. So what we can do next? At the next step, we can start to build machine learning experiment pipeline. What does it mean? In our experiment, even for this simple example, we have some stages that each stage do the simple data processing and the loading and processing, feature engineering, training, and evaluating. And so let's wrap all of this stage into one single module that we can call from terminal as a Python module, or call this as a function, and still continue to use our Jupyter Notebook. So at the end, we'll see that we have some general structure for every experiment we use, and every experiment will have some ETL tasks, some splitting, training, and evaluating with some different configurations. But in any project, we'll have more or less the same structure. And for our example, we'll put all the stages in SRC pipelines directory. It's also the custom name. You can change other, you can name it as stages, but usually I do it, put it into the pipelines folder. So for me, every stage in this experiment is a short pipeline. Sometimes it's not just load the data from sklearn data sets, but it's extracting data from databases, do some complex processing, and then saving some prepared data sets for the next stage. And how I organize these pipelines. First of all of these pipelines is actually the one Python model, Python file that has some function, the simple function that takes just few arguments like path to our param file, where we have all configurations. Inside of this function, it does all the logic that we need to for this stage. Actually, how to load, how to process, and where to save the final data. And this function we can import back into our Jupyter notebook, and we can call it in terminal with a common syntax for Python, like Python and name of our model. And for this structure, we can pass the config file or path to this config file into our module. And finally, it looks like this. In our terminal, we call Python -m that paths to this module, and the path to the params.yaml file. As soon as we run this command in the root of our project repo, so here we just use params. Okay, let's look into some, for example, data load pipeline. So here is actually quite simple, and it's the same actually from the slides. But let's navigate to training pipeline. For training, we have the similar signature. We use one function that takes one argument. Actually, that is a config path, and we extract using this config path to extract our config objects and extract from this config that all parameters we need, for example, for training. And at the end, we save our train model to the file to the path that we actually take from the config again. And this structure if name equal main with arguments that we pass to the our pipeline, it's actually the same. So I organize all pipelines in this way. So what are benefits for this approach? Let me go back to the Jupyter notebook, and let's continue review the Jupyter notebooks after these updates, after we created these pipelines. So first of all, we can load our params.yaml file and look inside, and so has the same structure. And then we can do data loading into the two ways, two methods. First, we can run this data load as a import this data load function from our pipeline src.pipelines module into the Jupyter notebook and call it as a function. And as the results, we'll have the data saved into this path. Or we can call this module in terminal. So in Jupyter notebook, we can use this exclamation mark as to run some terminal commands, and it will work the same. So we have the same behavior whether we use this calling this model via the function or calling via terminal interface. Or if you prefer to use the real terminal, we can just navigate to our terminal for our projects and just run this code. And actually, it's this work, and we can find our data sets in the data row data sets. That's it. So it means that we have, for now, we actually have very clean Jupyter notebook that we use only to run these pipelines. So now we can to prepare or to run new experiment. For example, if you want to add a new new estimator like SVM, random forest, etc., or to change configuration for existing estimator, you just go to the params.yaml file, change it here, and then run the cells with for training the model. And actually, it already allows you to do experimenting faster. You don't need, it's easy to navigate through these stages. It's easy to navigate to for configuration for your experiments. And but it's still the same experiment, and you get the same results for the same data, for example. Christopher, I can see your question. I cannot share the link for notebooks for now. Oh, I know, I have. Sorry, yes, I prepared it in advance. So please, this is the link. And I hope that Jupyter notebooks already there. Yes, there. Okay. So if you want to follow, please, you can follow by this link. Okay. What we cannot do with up to this moment, so at this approach, that, for example, if we change some test size from 0.3 to 0.02, and we can just, I don't know, somehow forgot that we need to rerun split train data set, and we'll try to do the training again. So now it's a here error because I didn't import the models, and here, not models, but to run these terminal commands, actually, I need to run them from the root of our repository. So I first need to do this CD. It's not the only way, but it's easiest way to navigate and to start running these commands. So up to this moment, we need to manually rerun each step for our experiment to make sure that we'll do everything correct and to get the final model and get this metrics for this model. It means that it still needs some manual operations. So it could be cool if we will, if we can automate this and automate this in a wise way. And for this purpose, to automate, we can use DVC. So DVC, probably, as you know, is the tool that can, so usually position as the tool for data version control. Is like a Git for data, but it has the very cool features related to pipelines and pipelines automation. And using DVC, you can first link the version of your data and code and config file, and you can automate how your experiments is running. So let's look inside. Because of this or common machine learning experiments is a simple pipelines as a sequence of stages, and at each stage we have something to input as a configuration file, so some parameters and data, and as output we also have some artifacts, data models, etc. So we can describe each stage in the for case, for example, in DVC, we can use some YAML file to describe each stage and describe what kind of inputs and outputs we have for this stage. And DVC will build the pipeline, the whole pipeline, and it will link different stages using these inputs and outputs. Actually, it looks very similar to the configuration of stages in Kubeflow that Imad showed us in the previous talk. And in DVC, we have a few ways to create the stages for pipeline. And the first one, as the historically the first one probably, is the DVC run command. For DVC run command, it has the few. It looks like this. For data load stage, we can use DVC run command. Name our stage as data load. And then we can specify some dependencies. So what inputs we should use for this stage. For inputs, we can specify any data as well as code. So Python code we use to run this stage is also the dependency. And also we can specify what is output of this stage. So for data load, it's iris CSV data file that we'll use later for feature engineering. And also it has some parameters and comments. Final comment that DVC should run using this configuration. As a comment here, we have the same command line interface command to run this data load stage. So the name of the command didn't change actually. So let's look into our Jupyter Notebook first, and then we'll look into the VS Code. Let's start with initializing the DVC. Actually, before you start to use DVC, first you have two requirements. First one, you need to have the Git repository already initialized. The second, you need to initialize DVC with DVC init command. And after you initialize DVC, it creates some metadata and some configs inside, and you need to commit these changes to the Git history. So after that, we can use DVC. Also for this tutorial, we will use DVC remote storage. And DVC remote storage is some storage in local or in cloud remote server that you can use to store as a persistent storage to track all your artifacts and data you want to keep for history, or you can control version for it. For us, we just create additional directory on our local machine, specify that we'll use this directory as a remote storage and name it as local remote, and then also commit these changes to the Git history. So I will not run this command, but I have already set up this. And after that, we need to create the DVC pipeline stages for each stage we had in our experiment. For it's a data load, it's a feature rise, data split. So actually, it's the same stages that we have. And for all of these stages, what we should take care about, first one, is the command we need to run. And actually, we call our pipeline models and pass our params.yaml file as a configuration file, and also specify dependencies and outputs, and specify the parameters. -p is the key that DVC uses to specify parameters, and it actually proposed that by default you use the configuration file name as a params YAML. So if you name this your config file as params YAML, so here you can just add the name of parameter section like a base. So let's look at again. So base is the top level section in params YAML file, or you can specify some parameters inside. So like featureize dot target column. So dot target column is actually the target. So this is the first method you can create the stages for DVC pipeline. Another approach, okay, let me show you. Okay, when you run this command, DVC actually creates a new records in dvc.yaml file. Let me show you. This is dvc.yaml file that actually contains the same configurations of how to run your pipeline stages in YAML file. So, and as soon as you run this command, dvc add stage or dvc run the data load with these configurations, you will get new dvc.yaml file and with this section inside. And here you can find that it's the same, the command. Depth is dependencies you specified. Here's the parameters and outputs for this stage. So actually this the same information, but DVC how to say that puts information about all your stages into this dvc.yaml file, and you can actually create new stages by manually editing this file. So you can name, for example, new section as featureize. So you want to create new stage featureize. You can specify the command you should run, dependencies, params, outputs. After that, DVC will consider that this is the valid featureize stage in the DVC pipeline. So okay, in DVC 2.0, so the last major release of DVC, it provides a new API to create the stages with DVC stage add. Actually, it's the same as DVC run I showed you on slides. But this is the new API that DVC will follow in next releases, and this DVC run will be deprecated. But until now, it works the same, and probably the most people still use DVC run. So how we can run all this configuration? So after we create all these stages, or after we specify all the stages in our dvc.yaml file, so how we can run them? And actually, this is very simple. We just need to run one command, which is dvc repro. And after when we run this command, DVC will start with the first stage, will resolve the inputs and outputs for each stage, build the DAG for your experiment, for your pipeline, and then run each command one by one, I mean each stage one by one. What is interesting? By doing that, first, DVC start automatically track the versions of all your dependencies and outputs that you specify here. And every time you do some changes that change your outputs, for example, like if you change the code that processes the data and at the result you have different RSCSV file that is used for featurizing and the training new models, DVC will find that this file was changed and rerun that all stages that are that depends on this changed file. If not, for example, it will see that okay, this file didn't change, so it means that there is no reason to rerun, for example, other files that if at other stages, if all the dependencies didn't change. So, and this mechanism can save you a lot of time. For example, if now we will run this DVC command, DVC repro command again, DVC shows that all stages didn't change from the last run, and it just keep it. It means that we save I don't know 10 seconds for this simple example, but when you have very heavy ETL pipelines and heavy experiments, you can save a lot of time. What we can do, for example, we can force, for example, rerunning all end-to-end pipeline again with -f key. In this case, DVC will rerun all our experiments and all stages, of course. But by the default, it will check that, for example, if nothing has changed, DVC will not run any of the stage that didn't changes. So how we can work with this? For example, let's check if we change the only one parameter. Let's take this one. This is the parameter in our estimator, and then we call again DVC. Easy to follow. Let's run DVC repro again. Oh, I forgot to say it. Oh, okay. I was expected that DVC will, so as soon as I change the configuration of our training section in params YAML, I expect that DVC will rerun the training stage, but it didn't. So why it was happened? Let's look inside our train stage in our DVC .yaml file, and we see that when we specify params for training stage, actually it should look inside of all our training section here, and it should be able to see that we changed our train stage. Okay, something went wrong. Okay, I'll check it later. Yeah, it's a bit strange, but okay, let's continue. Let's continue and let's talk about how DVC reproduce pipelines. So how this DVC repro command actually works. I will open my slides. And here we are. So this is, for example, our simple machine learning pipeline. And we have two options with DVC repro. First one, we can rerun or reproduce all our end-to-end pipeline. The second one, we want to reproduce only one stage. In both cases, it was the same. We just, for stage, we specify the name of stage we want to reproduce, and that's it. Without it, DVC will try to reproduce all pipeline. How DVC repro works? So DVC repro tries to reproduce the whole pipeline end-to-end, and to do this, it looks into the dependencies for each stage and check that whether these dependencies has changed or not. If everything is up to date, so it will not rerun the pipeline and skip every stage that seems didn't change. But in case if any dependencies change, for example, these trained data sets after we extract features. So, for example, I don't know, we change how we calculate some feature, and as a result, we have different trained data sets, and DVC will find these changes or detect these changes. It means that it will try to reproduce the train stages. Before it will rerun the train stage, it will first delete the model file that actually is output of the train. After that, it rerun the train, get the new model, and then it check that the model actually is dependency for evaluate stage, and it first delete the output of evaluate stage, then run it and get the evaluation report. And doing that, DVC will again keep all your pipeline up to date, and the next time you call this DVC repro command, it will not run it again. But if something changed, it will start from the stage that is actually has that's dependent on this change. So this mechanism is actually what I like in these features in DVC. Yeah, and as a bonus for because when each run, DVC keep the and do version control for each artifacts and outputs, and you can work with these versions in the way we use Git. So you can push it to the remote DVC repository to store this version of your files. You can pull them back. You can check out between different versions, and actually this may be what you actually need to keep track of the versions of your models and keep your versions, or for example, get the model you need for the versions of code that you work with at the moment. For example, when you do some deployment, you deploy or you clone some specific version of code into the remote server, Then you do DVC pull and DVC checkout, and DVC will bring the original versions of artifacts and models that you were generated with that commit of the code. So to make it easier to work with, it's better to keep all the stages first one, I would say deterministic, yes, that you freeze all random seeds and all dependencies and outputs. So you completely rewrite outputs, do not append or edit them, and you explicitly specify what exactly dependencies and outputs you have for each stage, and which of them DVC should look on to do version control, and whether it should do some caching or whether it should cache these versions of data or not. So there are a lot of, I don't know, functionality with these features of DVC that are out of scope of this talk. But at the end of this talk, we can see that we try to speed up our ML experiments, and this approach now helps us to change parameters for experiments only in param.yaml file, and then run DVC repro. And at the end, we have the new model, and we can start to reuse our code between the projects and between different models or pipelines inside the same repository, and keep these code versions. We try to make machine learning reproducible, and with automated run, we can be sure that each run of our experiment actually is reproducible and automated, and we don't do any, I don't know, manual mistakes, and we didn't forget to run some specific cell in notebook, and all our code data and artifacts are versions. And this also simplify collaboration. So first one, it's easy to configure everything in one param.yaml file. We can keep our repo structure clear, and it's easy to communicate with other people, and even follow some Git flow approaches from software engineering to make your in work on your machine learning projects.